I want to explain and demonstrate the different ways that we show bonding by drawing bonding structures for ionic and covalent compounds. The main difference is that for ionic compounds, we put the ions formed in square brackets and show the charge. This shows that we understand that the bonding happens between cations and anions, and that is electrostatic attraction. To draw covalent compounds, we draw overlapping orbitals, and we will do this by using something called the 5-step method. An example of drawing an ionic bonding structure will be to consider the bond that occurs between magnesium and sulfur. We know magnesium is in group 2 on the periodic table and has 2 valence electrons. Sulfur is in group 6 and has 6. So I'm starting by drawing the Lewis dot diagrams for each. Magnesium has 2 electrons to lose. It will lose this one and this one. When that happens, magnesium ends up missing 2 electrons and has an empty valence shell and a charge of +2. Now sulfur has 2 places to gain them, so fortunately these electrons both have a home to go to. Sulfur now will have its original 6 electrons plus the 2 that it gained from the magnesium and have a charge of -2. So because I've used square brackets and charges, I'm showing you I understand that this is ionic bonding between a metal and a non-metal. There's not always an equal amount of electrons gained and lost per each atom. For example, if I have calcium wanting to bond with chlorine, calcium has 2 electrons to lose. Chlorine in group 7 has 7 electrons and a space to gain 1. Well, calcium can lose 1 electron to this chlorine. The other electron has nowhere to go unless we give it another chlorine. So the 1 calcium loses both valence electrons to have a charge of +2, and we require 2 chlorines, each with their 7 valence electrons, each gaining 1 from the calcium to get a -1 charge. So again, even though I needed a 1-to-2 ratio, because this is an ionic compound, I'm using square brackets and showing charge. Let's go through the 5-step method to explain how to draw covalent bonds. Step 1 is to determine the amount of valence electrons. We do this by looking at the group or family that each element is found in. Phosphorus is found in group 5 on the periodic table and has 5 valence electrons. Chlorine is found in group 7 on the periodic table and has 7 valence electrons. There are 3 of them for a total of 21 electrons from the chlorine. This gives us a total of 26 valence electrons to use when drawing the atom. We're now going to put phosphorus in the middle and surround it by chlorines. Technically, this is because phosphorus has the lowest electronegativity of the 2 atoms. Usually, however, it's pretty self-evident which one goes in the middle. The only time that the lowest electronegative doesn't go in the middle is hydrogen. Hydrogen's always terminal, or an outside atom, because it only can have 2 electrons, so it can't make more than 1 bond. We connect our atoms by drawing bonds. Now, a single bond is a group of 2 electrons. So I created a bond here between the chlorine and the phosphorus by putting 2 of my electrons. And I'll do that between each chlorine with the central phosphorus. So now I've used up 6 of my electrons. Who gets them next? Well, because I put the ones with the higher electronegativity on the outside, they're going to get next dibs on the electrons. So I'm going to complete the octets surrounding those chlorines and see how many electrons that we've used. Remember, we already had these 6 electrons. Completing the octets, we are at 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We've now used up 24 of my 26 electrons. I have 2 electrons left, and if you have extra electrons now, they always attach to your central atom. We call these lone pairs because they're not being used for bonding. So now I have used up all 26 of my electrons. Checking my way around each atom, I can see that this chlorine has 2, 4, 6, 8. Its octet is full. Chlorine, 2, 4, 6, 8. This chlorine, 2, 4, 6, 8. And then checking the phosphorus, 2, 4, 6, 8. These all have full octets. We have completed all of the electrons we had available, and every atom has a full octet. So even though I said this was a 5-step process, in this case we managed to draw the structure using only 4. Let's do an example where we have to use the 5th step. Carbon dioxide. In the carbon, there are 4 valence electrons, and each oxygen, being in group 6, has 6 for a total of 12. This gives us 16 electrons to play with when drawing the atom. Carbon has the lowest electronegativity and goes in the middle with an oxygen on each side, and I join them with single bonds. A single bond is a pair of electrons. So I'm going to use one pair of electrons here and another one there. I've used 4 of my 16. Next, I complete the octets on my terminal atoms. So I had these 4 already. Putting the remainder electrons around the outside, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We've now used up all 16 electrons. We have no lone pairs to attach to the carbon. The problem happens, though, that although each oxygen is surrounded by an octet, the carbon is not. Our carbon atom has only 4 electrons around it. So what do we do? In order for this molecule to be stable, every atom must be able to look around it and count 8 electrons. What we do is we migrate. We're going to take a pair of electrons from each oxygen and bring it in towards the central carbon. So drawing this in the form that we've been using, we had the carbon with the original 4. We have a pair here and here, and we'll migrate one in to the side. This makes a total at this point of 2, 4, 6 carbons, electrons around the carbon. Continuing on, we do this on the other side as well, migrating a pair in. These groups of 4 electrons are a double bond. Each line is considered a group of 2 electrons, or 1 bond. Because I've drawn 2 lines, this would be considered a double bond. Sometimes we actually need to form a triple bond. Going through the steps to solve for this one. Hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. This would give us a total of 10 electrons. I chose to put carbon in the middle. I knew it couldn't be hydrogen because hydrogen can never be a middle atom. Between carbon and nitrogen, carbon has the lower electronegativity. So I start by putting my hydrogen, my carbon, and my nitrogen with carbon in the middle and attaching them with single bonds. That uses up 4 of my 10 electrons. Hydrogen's outer shell is full with 2. Nitrogen gets next dibs at the electrons, so I complete its octet by adding 6 more electrons. This now gives me a total of 10 electrons. But although nitrogen has 8 electrons surrounding it, carbon only has 4. So we have to start migrating. Moving a pair of electrons towards the center keeps 8 around the nitrogen, and carbon is up to 6. We're still not at enough, so I'm going to migrate 1 more pair into the center. At this point, I can circle 8 electrons around a nitrogen, 8 electrons around a carbon, and of course 2 around a hydrogen. Because there are 6 pairs of electrons, we have a triple bond. Even our polyatomic ions, although in square brackets because they're used in ionic bonding, within their own structure are typically bonded covalently. In the iodate ion, iodine has 7 valence electrons. Each oxygen has 6. 3 of them makes 18. And this -1 charge means that we get to add 1 more electron. A negative charge means that you get to add extra electrons. -1 means add 1. When we're done drawing the structure, we put the entire structure into square brackets with the charge on the outside so it can be used in ionic bonding. To help practice drawing ionic and covalent bonding structures, first decide if the following 5 molecules are ionic or covalently bonded. Then, if it's ionic, use the square brackets, and if it's covalent, practice drawing these using the 5-step method.